So we're going to simulate by MATLAB. The result is like this. The basic user interface settings are from this source code. It was originally for simulating physics of one ball falling. You can find the code from this link. This is the UI setting part in the code. I add some lines to control the second ball's size, initial velocity, and other parameters. The callback property means that the function follows will run when the user interacts with the UI control. This is a function for setting up the ball size, axis range, and draw the two balls or some lines. The word varying means that this function accepts any amount of inputs. We use string to double to get the content inside UI control, and then the function line space creates a linearly spaced vector starts from 0 to 2 pi, which allows us to draw a circle. These two lines indicate the color of the ball, and these two lines indicate the x data or y data of the ball itself. We use the fill function to draw two circles at the position we want. This line draws a black line which indicates the ground. The following line draws a dashed line which indicates the start position of the larger ball. H2 and H22 is a plus sign which indicates the center of the ball. Then we are going to see the main function. TB is the push button. If it is clicked, this function will run and set the text on the button to be stopped. DT is the time scale. The ball will go forward for its velocity times dt each time. Others are the initial speed, or gravity, or elasticity, and so on. M1 and M2 is the mass of the two balls. These are the mass of official ball of basketball and tennis ball. The first four lines are for plotting out the path. First, we change the velocity of the ball by its acceleration times time scale, which we set as 1. Second, if the larger ball will hit the ground after moving, we calculate the new velocity of the ball. If the ball is not going to hit the ground, decrease its y position by velocity times time scale. Then we check whether the smaller ball is going to collide with the larger ball. Here we assume that there is no energy loss in the process of colliding. If it is going to hit the larger ball, set the velocity by the equations of momentum conservation. If it is not, show the velocity of the smaller ball and update its y position. The clip shows what will happen if we drop these balls from 1 meter high. If we give these balls the same x velocity and plot out the path, we can observe the relation of y position and time more clearly. We also try to drop the ball from a higher position. Since the tennis ball is too small to see, so we make another version like this. The radius is scaled up by a factor of 10.